research should be done at a reasonable cost. There is a point where you are taking away resources from other more worthy projects, so it should be done at a reasonable cost. The number one reason that I'm not working at Google anymore is because I put my foot down and said, no, we're going to do this research open source, and I'm not going to negotiate on that. Right? And they were like, well, that's fine, but you can't do the open source research here. In my mind, humanity clearly wins, the field clearly wins when we work together. And we need to do more of that, not less of that. Right now, there are many different superconducting qubit groups, all doing research with a lot of secrecy. That's a lot of duplicate spending, right? A lot of duplicate talent solving the same problem. And that's very unfortunate. It would be much better if the field was run more like CERN, more like IDA, more like the International Space Station was run, as a global international collaboration of academics that all most definitely share everything. We would get a quantum computer objectively and obviously a lot quicker if we did that. Right? There's no question about that. It would require fewer people, fewer dollars, the result would be faster. I'm not saying we have to choose one particular technology, but in any given technology right now, there are many neutral atom groups, there are many ion trap groups, there are many superconducting groups, many quantum dot groups, many. We've got hundreds and hundreds of groups around the world all trying to do very overlapping research. And it is extremely difficult to see how all of that money spent on all of that duplicate research could ever possibly be paid back.
Yeah, and also the irony is that in a different scale, like these talents are also very scarce.
That's right.
Yeah, what do you think are the big forces that is sort of preventing this kind of open source approach, like this ideal situation from unfolding?
Yeah, to be frank, I think it is the way physicists went about raising the capital to do their work they wanted to do. So it was hyped up the cryptography aspect. It's hyped up the computational revolutionary aspect. So the promise of vast riches through quantum computing has become an accepted part of popular culture. And so companies are now able to and are raising hundreds of millions of dollars and sometimes more to build that quantum computer and reap those riches that have been promised. So if there was one central mistake, it would be that. Because the reality is, Shor's algorithm was invented in 1994. It is 2025. That is 31 years later. 31 years later, typical state of the art for a quantum computer is around 100 qubits. We need 1 million. Maybe 10,000 if you're very lucky and have arbitrary range interactions. And as yet, over 3 decades later, there is not a single known quantum algorithm where you can say this specific classical algorithm, which is run routinely and costs this much to run, would be cheaper to run on a quantum computer. Not one. And yet, everyone is convinced they're going to make so very much money building a quantum computer.
Quantum rush.
Right? It would be much more reasonable to say that quantum computing objectively can do certain things exponentially faster than a classical computer. Isn't that fascinating? This will have an impact on computer science. This will have an impact on mathematics. It could have an impact on certain areas of physics research. We should build one of these as an international collaboration to bring people together. And in 2025, we definitely need reasons to bring ourselves together because of all the wonderful fundamental things we'll learn. Right? And unfortunately, that is not the path we took when it came to where do we get the money for quantum computing.
Right. Maybe government should step up in this regard to really foster something.
It would be extremely reasonable, in my mind, for the governments of the world to look at how much money they have put into the quantum ecosystem and say, you know what? How about we pool our resources? Yeah. How about we make it a national project? Let's choose, the half a dozen most popular ways of building a quantum computer. Choose all of them and get the very best from everywhere to have the very best shot at doing these things and publish everything. Because in my strong opinion, at the moment, the world is spending way, way, way more on quantum computing than it should be.
Right, and they're duplicative in many cases.
Duplicative. It's a talent drain, it's a resource drain. And it has got to the point where we should acknowledge that and strongly think about better ways of doing it. And the TQEC project, as a totally open source, volunteer-based project, is an example. There is no reason that this couldn't be a model for academic research in hardware as well. Even in academia, there is a certain push to patent, keep secret, protect your IP, not talk about the details for fear of competition with other academic labs for funding, right? It's a real competition. And that needs to be solved at the funding level so people don't feel the necessity to do that.
But does that also happen for like other fields? Like my main concern, I'm also involved in some open source projects. And then what happens is like, okay, I'm providing open source project for the people. And then they would, based on whatever like the software like developed, they can build a closed software on top of that. And then, for example, whoever like developed the open source doesn't really have access to the closed ones. Like you don't know, it's just like a black box. It works, like for example, 10 times better than what you built, but
it depends on the scale and the professionalism of the open source group.
Yeah.
The TQEC group in terms of interested members is over 1,000 people. In terms of actual hands-on coders, we're about 24 people. So it's not a small effort. And there's no reason that can't grow to the point where, I'm sorry, but you're not going to be able to compete with it, right? So, you have to produce a quality tool. And history has done that. Everything from the Linux operating system to GCC.
Yeah.
There are multi-decade, very mature open source projects where people don't compete with them. These are industry standard.
Yeah, I agree. Linux is probably one of the great examples of the open source community.
So you have to take the open source seriously. And right now, the TQEC project is at the stage of doing research on the low-level circuits to realize the fault-tolerant gates. Then once all of those have been worked out, and that's still a process that's ongoing, we will come back and re-engineer the code base to run faster, streaming, and make it really useful to people everywhere. But yeah, right now it's absolutely collective research, and I don't know any way that this research could have been done differently to the way it's currently done. It's best done as an open source project. There's been good ideas, even just in the last week, within the TQEC group that are genuine community contributions that make the TQEC tool state-of-the-art. So you have to take the software seriously. You certainly don't want it to be the case that one or two people paid behind closed doors can suddenly turn your software into something that's 10 times better. I don't believe that's the case for TQEC.